So now welcome to our harder example about congruent triangles. This one is quite tricky. So here we have two squares. We have A, B, C, D, and then the square, B, G, F, E. Okay. Also, we have these triangles that are kind of set up between them. So we have B, C, E, this one here, and then we have the triangle A, B, G. Okay, see those kind of awkward looking triangles? So we're given those two squares and we have to prove that the triangles ABG is congruent to the triangle BCE. Okay, so again, I'll just draw those out. So we're going to have this triangle ABG, this one here. Again, it's kind of messy, but it's just to show you the idea. It should be congruent to the triangle BEC. Okay, so they kind of overlap a little bit and they share the two squares. So how are we going to do this? So I'll go back. This one's definitely a lot harder than the other ones. So the first thing I'm going to do is I'm going to draw the two triangles out separately. So I'm going to draw the triangle ABG. So it's going to be something like this. And then I'm going to draw this triangle here, which is going to be BCE. Okay. So for both of these, B is going to be the top one. So remember, for this one, we're going to have A over here and G at the bottom. And for this one here, I'm going to put C over here and E over there. Okay, can everyone see what I'm doing there? So I'm drawing out this triangle down here. And then I'm drawing out, I'll use a different color. It's not very clear. This triangle here. Down here. Okay, and this will save us a lot of hassle just trying to tell which triangle is which just by doing that here. Okay, so I'll get rid of those. Okay, so now how are we going to prove that these two triangles are the same? So that's where the tricky bit comes in. So the first thing I'm going to focus on is proving that this angle here, okay, actually I'll choose a different color. I'm going to choose dark blue. So this angle here, if we see that, so that's going to be ABG is the same as this angle here in red, EBC. Okay, so first I'm just going to write out what this angle ABG is. So I'm going to say, I'll go in blue, that the angle ABG is equal to 90 degrees plus, so where I'm getting that from is this angle ABG is equal to this bit here, which is 90 degrees, plus, so if I just get rid of these things, so sorry, yeah, it's 90 degrees, which is the ABC, plus this little bit in the middle. Yeah, so it's the 90 degrees plus this little angle here, which is CBG. Okay, I'm going to write that, so it's going to be 90 degrees plus the angle CBG, which is, that should be G here, which is that little bit in the middle. And now for the red one, the red angle is, that's EBC, okay? So I'm going to say that the angle EBC, and sorry, just that should be G, my bad. So the angle EBC is also equal to 90 degrees plus the angle CBG. Because if you look at that, so again, it has its own 90 degree little bit, the right angle, and then it also has the little angle in between. Okay, so that's what that red angle is made up of. So we can say that that's true. And now I'm going to finish off by saying that means the size of the angle ABG is equal to the size of the angle EBC. Yeah, dot, and then it's going to say that that is A. Okay, so that means we have an angle that is common between the two of them. So I'm going to draw that in on the diagram. So I'm going to say that ABG, which is over here, I'm going to put a dot there, and then EBC or CBE, which is this angle here. Okay, so that angle is the same in both triangles, which is what we just proved here. Okay, so that's the first step. Now we have to prove that some of the sides are the same. I'm going to go back up and look at our triangle here. So we know that on a square all sides are the same, so that means that this side here, AB, is the same as this side here, BC, is the same as DC and AD. Okay, so we don't really care about AD and DC, but we do care about this here, AB and BC. Okay, so see here, I have one green line in each of them because they're the same length. I'm also going to put that down here. I'm going to say that AB, remember this is the same line, I've just drawn it down here, and also this line here, BC. Okay, so right now I've just proven that AB is the same as BC, and the reason is because they're both part of the same square. Okay, so I'm going to have to write that down here. So I'm going to say that the side AB is equal to the side BC, dot, dot, dot. I'm going to say sides of same square. And then afterwards, in brackets, I'm just going to put in S. So that means we have a common side between the two. Okay, so now we have A and S. So all we need is one more A or one more S, depending, to prove that they're congruent. So now I'm going to go back up, look at the same thing again. So now we have a square BEFG, and we know again that every side in the square is the same. So I'm going to put 2 lines there. I'm going to put 2 lines there. That's on the other side of the square. 2 lines here, and 2 lines here. So again, we don't really care about these last two. We just care about BE and BG because they're part of the triangles. So we have this line here, BE, okay, is the same as this line here, BG. So if I go down to the diagram and draw that, so we have a line BG that should have 2 purple lines through it, and also the line BE that should have 2 purple lines through it. Okay, and now again we've just proven that this line is the same length as this line, so I'm just going to have to write that quickly. I'm going to say that the length of the side BG is equal to the length of the side BE, dot, 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 and again I'm going to say sides of same square. And now we have another S, and as we can see here, we have a side, an angle, and a side, and the angle is between the two sides, so that means we can say, I'm going to say that therefore the triangle ABG, G, is congruent to the triangle BCE, and dot, 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 SAS. Okay, so we just proved that those two are congruent. So that one is definitely a harder example. It's quite tricky to spot that little trick there, but again, it's just practice being able to see things like that. If you do loads of examples, things like that will become more clear. One trick that definitely helps is drawing out the 2 triangles separately. It'll help you in pretty much any situation, any geometry question you get. If you draw the things out separately that you want to prove they're congruent, that'll always help. But yeah, besides that, it's just practice being able to see those little things in the question. So the rules will only take you so far. After that, it's practice and be able to see these little things in each question. So I'm going to leave it there for congruent triangles. In the next few videos, we're going to look at parallelograms. So yeah, if you have any more questions on congruent triangles, leave them down in the comments. Share them with your friends if you thought they were helpful, and like and subscribe to the page. But yeah, besides that, we'll see you in the next video where we're going to start talking about parallelograms.